All right, so exercise 9.50, problem 1 from the technical drawing book. You'll see I have a few options already set here that I want you to abide by. We've got the thickness, the bend radius, K factor, and the seam size. So, we'll plug those in as we go. And then I've got some files attached here. And essentially, this is the guy we're working on. It's an intersection. We're going to make it as sheet metal. So it won't look exactly like this, but it'll be the same dimensions. If you notice in the book, they actually don't show how these two parts meet. It's because it's really freaking hard to tell. But, it's one of those things where when you're modeling it, you just see where it lands, and that gives you your basis for everything. So technically, if you're drawing this in AutoCAD, it would be this little vertex here, and it would connect like a slant both ways. But for what we're doing, it'll look like this. And this is the other attachment that's provided, and it's the DWF. So I'm going to put some edges on it. And essentially, it's a 3-part assembly. You might think that these two would be the same, but they're not. Because you have this 30-degree angle, it's actually got to be 3 parts. And there's nothing in the middle. So essentially, it acts like a cross, connecting 4 directions. Okay, so let's go ahead and talk about the methodology behind it. So here's my assembly. I'm going to open up all the parts and then we'll model it up. One thing I will note, when I originally did this, I made this part the hard way. So we'll do it the easy way. And so I won't even talk about it. So the premise is straightforward. You're going to draw a sketch for the square shape on the bottom. You'll do an offset plane. You'll draw that same sketch up here. Do a lofted flange, making sure that it's within the extents of that sketch. A rip, of course, so you can unfold it. And then I made a midplane. This is actually more for constraining, but good to have. And then there'll be a sketch to simulate the other piece, which is also a square, but this time I have to draw in all the detail in order to cut it properly. And then simply just cut it through. Well, dang it. There we go. So I drew it over here. When we do ours, we'll just do it in the middle. It doesn't really matter where you draw it. What I did when I made it was I just copied the sketch from the other part, so I didn't have to work as hard. So no biggie there. And then naturally unfold it. It looks kind of goofy. And this part is where you can really tell the difference between like real world versus not. So like, when you're looking at this, we have these weird curves, okay? And technically you could do a cut normal and that would allow it to not have that deformation. But the problem is then your shape is different and it doesn't quite fit. So if you see, it's actually bigger. So we don't want to do the cut normal, so I'll just turn that off. And then the same thing kind of applies to this guy. If we don't do cut normal, it has this weird shape, but it's a lot more fit up and it's a lot more advanced. We won't bother with doing that basically, but in the real world, when you're actually working, they would probably do cut normal so that whenever they go and burn it out, the ends are square, because obviously no one's going to go through and just shave the ends off like this. It's just not going to happen. So for this part, it's the same concept. We'll do a sketch of the profile, an offset plane doing the other sketch of the profile, do a loft between them. And note this plane here is actually the middle of the part. And then we would do, again, the same concept, drawing the profile of this one. And then just cut through and, unfold it after you do your rip. It's pretty straightforward. And it shouldn't take us too long to do these. So I'm just going to close all this hoopla. And let's move this so I can see it. Okay. So I'm going to start a new part, and these are in imperial units. I'm going to convert to sheet metal. And then we'll start the vertical column first. So the thing I like to do here, no matter what, if I can, is always use the center and then the 2-point center rectangle. So I'm going to do a center and just click, and then we obviously, looking at this one, we need it to be vertical between this point and this point. So I'm going to delete a constraint so that we can do that. So somewhere on here, you should have a horizontal or vertical that comes in. Delete it. And you know, if you're unfamiliar, you can hide and show constraints. That's what I hit there to do that. So I'll just pull this kind of into position, do a vertical, and then I'll go ahead and set my two sides to equal each other. And then we'll dimension it. So it's a value of 1.5. And you know, pause. Let's switch directions. I kind of always forget about this myself, but let's change the sheet metal defaults. So looking at you know, the assignment, we need to do a thickness of 0.1046. The bend radius equals that, and then the K factors are already defaulted to 0.44. So we just need to change the seam size. So we'll change the material to steel mild. Thickness to 0.1046, and then, you know, the bend radius is set to equal thickness. We're good there. The K factor is already set up right, so we'll just do 0.0625 for the miter right rip seam gap, and we can close that. So now we just need to do an offset, going from the, you know, this is the bottom of that vertical part, so we need to offset the full height of 3. Draw on that sketch, project the square. And we'll turn the visibility of that plane off. It's quite the eyesore. Do a lofted flange, make sure it's on die formed. Flip direction so that it's within the boundaries. And we've got the main tube. So next we'll do a sketch here on the mid plane, bisecting the part. And I'm going to draw it out in space just to make my life a little easier. But we'll do another square shape, and this will be the one that has more detail. Okay, so looking at this part, we know that it's 1 across, but we need that angle put in. So let's go ahead and project some edges here from the original part. Well, actually, thought it would grab a little more. Let's get the bend too. Okay, so what we're going to do is just draw a vertical line to give us a reference point, and then we'll trim it. And it appears that we need to put a vertical on it. I'm not sure what happened there. Okay, I'm going to make this a construction line. Then I'll constrain the center of our rectangle to it. I'll dimension to the center to give it the 1.5 so it's in the middle. And then the last thing we need is the angle. And I'm going to just manipulate this a little bit to get it in a better spot. Kind of like similar to how it looks in the book. You know, it's got a lean and we've got a 30 there. So now I'll dimension and put in that 30 degrees. Okay, so now we've got it constrained and we can go ahead and finish shaping it. So both parts have the same thicknesses, sheet metal defaults, all that. So what we need to do is make the outside bend, because this is the outside square, and then we can offset it in. So I'm going to make that offset bend or outside bend using the math that is involved in it. So when you're looking at sheet metal, the outside radius of a bend is always going to be the thickness of the part plus the bend radius. So we can actually just type in the parameters built in. So bend radius plus thickness. Oop. Well, I goofed because I forgot to actually click the stuff. So we'll do that again. Bend radius plus thickness. Don't hit enter like me and start clicking your, boo. There we go. Clicking your edges. And it's going to jump around the shape. Don't worry about that. Just keep on pressing on And then we can do an offset and just type in that thickness parameter. And then we can go ahead and jump and do a cut. So I'll choose both profiles. I'll do all, both ways, and hit OK. And as you can see, very lovely part. We just need to do a rip and unfold it. So this is our front view. I think that I'm going to put my rip right here. And I'm just going to put it in the middle of that line. The outside line. I'll do the rip command, choose the point and the face. Huh. Did I forget to save the gap size? Weird. Okay, let's do that again. Why so big? Maybe it's just a graphical error. No, it's not. What in the world? I've never seen it do that. Huh. So you see it's supposed to be that size, and it's not when we do flip. I'm going to delete that sketch. I've never seen it do that. I've worked with sheet metal for years, and I've never seen that. Okay. We'll do the point again. This time I'm going to, I guess, try to constrain it a little more cautiously. What? Wow. I guess if you have this problem, you can always just do it on a different face. This is peculiar. All right, let's try it this way. I see now. It's having problems because of this face being here. So how do we want to fix that? I suppose what we can do is suppress that cut, and then we'll do it, and then we'll go back to it. So we're going to go back to that original face. We'll do the rip, and then we'll unsuppress that. Call that a workaround. Kind of silly, but hey, we got there, right? Okay, so we'll save it. And I'm just going to put it in my downloads since I'm not, keeping this. So I'm just going to call it vertical. Okay, I'll go ahead and open up an assembly. Paste this guy in. And, it's up to you if you want to reuse some of this or not. I think I will. I'm just going to save a copy of this part so I don't have to redo the sheet metal defaults. Horizontal. We'll open up that one. And I'm going to delete most of this. So I move the end of folded above it. Right click, delete all features below. And we'll delete the sketch too. Okay, so now, since we're going to make the other part, we need to start in the middle. And we'll do the same trick. And if you recall, this one has that angle, so I'm going to kind of position it in the right way. And I'll draw an arbitrarily long vertical line. We'll size this up. All right, I'll put in that 30. We'll set these to equal each other. And then I'm going to trim that little line up here. Okay. So now we can do the offset from that plane. And looking again, you know, so from the middle to here is half of 4, which is 2. So I'm going to do, the arrow is facing this direction, so I'm going to do -2 in this case. I don't know why. I always prefer to work on the left side, so you can do it either way, it doesn't matter. And then I'll do another sketch and project the lines. Oop, I did not mean to create a note. Boo. Turn off the visibility. That darn note. Delete that note. We don't want that. Do our lofted flange. Diaphragm flipped inward. And take note, you know, if you didn't do a save copy as like I did, you would need to go and redo the sheet metal defaults. So something to keep in mind. And I'm going to go ahead and put the rip in. So we'll put it, let's do it on the bottom end. There we go. All right. You know what? Did I make my flat pattern? I did not. Okay, so on this guy, you know, don't forget, create the flat pattern. Okay. So now for this guy, we need to do a sketch on the origin plane. And I'm going to slice the graphic so I can see a little better. We'll draw a rectangle. Delete the horizontal constraint. Do a vertical between the top and bottom point, which I think I may have missed. Let's see. Oh, I got it. Okay, cool. We'll do an equal. Size it up. And then we will create the fillets using that same formula. So that is thickness plus bend radius. And if you're ever unsure if you got it right, what you can do is just check afterwards. So we can do our offset, type in thickness, and then, you know, when you measure this inside radius, it should be 0.1046 like we want in our defaults. And as you can see, it is. There's a little bit of round off, it, you know, from what we have as the default settings, but it is 0.1046. And then we can do a cut. Let's see. So I'll choose both faces. I'll do all both ways. And now we're cooking. So, you know, naturally the next part is to get everything constrained into place. I'm going to turn on shaded with edges. And then, you know, usually it grounds the first component. We don't really want to do that. We need to manually constrain it to the actual origin. So let's do that. I'll use this part as my basis to constrain to the assembly origin. And it should be as easy as choosing the two corresponding planes and choosing flush every time. So XZ to XZ, XY to XY, and OK. So now, you know, it doesn't move. I can minimize my assembly origin folder, and we'll constrain these two together. It's a little bit easier if we add in a few work planes here. So because we're going to constrain to the middle of this, instead of having to do a lot of effort, we can just do a mid plane between two planes. We can choose work plane 1 and whichever origin plane it was, XZ in my case. And now we have a midpoint to work with. And I think that's all we'll need. We'll see. Okay, so the horizontal, we'll first do this YZ to the center of the vertical. And we need to make it flush. we'll do this one. And here's that work plane we're going to use. And then we'll do this guy. Okay. So you may be thinking, man, that is a lot of work to draw the same thing backwards. You know, technically it's not. You could save a copy. You could flip your plane the other direction. You'd probably have to redo some of your features, but it would generally work pretty well. But one thing you can do, and you know, it's debatable if some companies accept the use of it or not, but it is lovely if you use it the right way. We're going to do a mirror. And it works a little bit differently with parts. The way it works with, you know, features, it just does it. There's no associativity. There is with parts. So when I click this and I choose a mirror plane, you can see it's doing some weird stuff, right? I'm going to choose mirror plane. So what it does, it creates a copy of this component, but there's a dependency. So if I change this one, it would change this one. It makes a new file, but there definitely is a dependency. So what you typically need to do is give it a name, give it a file name, give it a location. You can go and choose these, whatever. I'm going to keep mine as is because, again, I'm not, you know, trying to keep this part. But if I wanted to change any of them, I would do it now. And then it immediately creates it. It's a new part. If I go to the iProperties, you know, it shows the name as horizontal_mirror. And if I were to, you know, change this one and remove any kind of associativity, it would keep its own independent state. So keep that in mind. They are two parts. The only thing is when you do a mirror, it creates the part, but it actually doesn't constrain it. There's an option to ground it, but obviously you don't want to ground anything. So we'll now go and constrain it. All right, breaking out the goods. So we'll do these planes. And I need to flip it to mate in this case because the part is backwards compared to the other one. Okay. Our seam should match up, so I need to do a flush. And then, what's the last one? Actually, I don't remember. There we go. Okay, so this direction. There we go. Okay. So now, how do you know that this guy and this guy are aligned? Well, we just check. We measure. So I'll measure from this face to this face, and it should show 0. I'll do the same thing from here to here, and it should show 0. And assuming that's the case, you should be able to go in a side view, hide the visibility, and it should look the same at these edges, you know, when you hide it or unhide it. And I can do the same thing here, but obviously we can tell that, you know, things are aligned. So very lovely. If I were to go and do a section view, cutting through the cross, you should see this very lovely meeting point area. You know, you've got like, if they were actually making this part in a shop, what they would do, you know, is weld most likely on this butting point where they butt together all the way around, and then probably on the outside too, you know. So what you get is a nice edge for a welder to go and do their job well. So keep that in mind, that there should be no protrusions inside. You are working on having a seamless intersection, which we now have. So I'll end my section view. And, you know, that's pretty much the premise of this one. You know, if anybody's having any questions about how to go about anything, just let me know.